So now let's try subtracting rational expressions. Here we have two rational expressions, and before we can subtract them, we have to get them to have a common denominator. Now to find the common denominator, we're going to have to find the least common multiple of both of these denominators. Now the easiest way to do this is first to factor both of these denominators. Our first one will factor into an x plus 4 and a x minus 2. Our second denominator will factor into a 5 times x squared minus x minus 2. And the x squared minus x minus 2 will factor, so this will factor into a 5 times x minus 2 times x plus 1. So my least common multiple then will be 5 times x plus 4 times x minus 2 times x plus 1. And this least common multiple is going to be the common denominator for both of these rational functions. So if we want to get our first rational function to have this denominator, we're going to have to multiply this one by 5 and by x plus 1 in both the numerator and the denominator. If I do this, I'll end up with my common denominator, 5 times x plus 4 times x minus 2 times x plus 1, and this will be over our original expression, x squared plus 4x, multiplied by 5 times x plus 1. Next, I'm going to subtract my second expression, and when I multiply it, it's going to end up with the same common denominator, 5 times x plus 4 times x minus 2 times x plus 1. But in my numerator, I'm going to have my original expression, negative 4x minus 16, and then multiply everything I multiplied my denominator by to get it to this common denominator. Well, I multiplied it by x plus 4. So I have these two rational expressions now all over the same denominator, so I can just subtract them. But it's hard to subtract binomials and polynomials, so instead I'm going to add these two expressions, but I'm going to multiply my second numerator by negative 1. Then I'm going to distribute this negative 1 inside, and this second term will become 4x plus 16 times x plus 4. Now again, when I add my numerators, I'll just be adding x squared plus 4x times 5 times x plus 1. And all of this is over 5 times x plus 4 times x minus 2 times x plus 1. Now before I can add these, I'm going to have to multiply them out. So for my first rational expression, I'm going to distribute this 5 inside. So this will be x squared plus 4x, and that will be multiplied by 5x plus 5. Then I'm going to FOIL these two binomials out. So we'll have x squared times 5x, that's 5x cubed. X squared times 5, that's 5x squared. 4x times 5x, that's 20x squared. And 4x times 5, that's 20x. Now my other numerator, 4x plus 16 times x plus 4, I'm going to FOIL those out. 4x times x would be 4x squared. 4x times 4 would be 16x. 16 times x is 16x. And 16 times 4 is 64. Now I need to add like terms. I only have one cubed term, so we're going to have 5x cubed. We have a 5x squared, a 20x squared, that's 25x squared, plus 4x squared, that's 29x squared. We have a 20x, a 16x, and another 16x. 16 is 16 would be 32, plus 20 would be 52x, and then plus 64. This is all over 5 times x plus 4 times x minus 2 times x plus 1. Now you could FOIL out your denominator if you want to, but you don't need to. This would be our solution for our subtraction. Now the last thing we have to talk about is simplifying complex fractions. Here we have 2 over y minus 3, and that's all divided by 4 over x plus 5. Now the easiest way to do this is to multiply both the top and the bottom by our least common multiple. Now to find our least common multiple, we're going to put this 3 over 1, and we're going to put this 5 over 1. Now we need the least common multiple of all 4 of these fractions. My first fraction, 2 over y, my least common multiple would be y. For 3 over 1, my least common multiple would be 1. For 4 over x, that would add an x to my least common multiple. And then 5 over 1, we're adding a 1 to our denominator, but we already have it. So our least common multiple is going to be xy. So I'm going to multiply both the top and bottom of this equation by x times y. If I do this in my numerator, I'll have 2 over y minus 3 times xy. Now I have to distribute this xy inside the parentheses. If I do that, x times y times 2 over y will just be 2x. And then negative 3 times xy would be a minus 3xy. My denominator, 4 over x plus 5, that's multiplied by xy. So again, I have to distribute my xy across this addition. If I do that, I'll have 4 times xy divided by x, or just 4y. And that'll be plus 5 times xy, or 5xy. So my fraction now looks like 2x minus 3xy over 4y plus 5xy. Now normally you would have to simplify this, but it's actually already simplified, or cannot be simplified any further. So this would be our solution for our complex fraction. And that completes the tutorial on addition and subtraction of rational functions.